Hey everyone, my name's Brian Parks. Lots of good talks on good, scalable, maintainable, and testable microservices architectures are out there. I've watched a bunch of them on YouTube. A lot of them come from development conferences from all over. And some even mentioned that the products and services that they're talking about in their talks started out as a monolith and then gradually migrated to microservices, or was rewritten as a microservices architecture in one fell swoop. But few of them, if any, talk about the transition, the actual steps that they took to go from the monolith that was built originally over to the microservices architecture. Now, that's not to say that monoliths are unequivocally bad. Monoliths definitely have some upsides. They can be easy to distribute. They have a single point of onboarding for new developers or even new people, selling your product or service. Depending on how your company is structured, engineering might be one large team. Or behave as one large team, even if you have smaller, agile or scrum teams or something like that, that enable better cross communication and that sort of thing. But they do present some challenges, especially when you're talking about software as a service. They can be hard to test because monoliths tend to be a single, tightly coupled code base. It can be hard to break those pieces out and test each one individually. And because of that, it can be hard to maintain because in order to add a feature or fix a bug, you might have to write code in many different layers or change things in many different classes or functions rather than being able to go to a singular source of a bug or where a feature needs to be added, adding it, and moving on with your life. It can also be hard to change if you want to add a feature, right? And it can be difficult to scale because everything's tightly coupled. It can be hard to scale out just the pieces that need to be scaled out. And depending on how it was implemented, even if you wanted to just take the monolith and install it on a bunch of different machines and scale it out that way, depending on some of the design decisions made early on, you might not be able to do that. So the key point of this video is that it is possible to escape from the downfalls of a monolith without also falling victims to the downfalls of microservices, because there are some downfalls of microservices. One of the chief goals of moving to a microservices architecture is obviously being able to scale up, but scale goes both ways, and in some cases you might want to scale down. But if you are specifically focused on getting to a whole collection of microservices, it might be difficult to scale down beyond just having a single instance of each service. To do this, we'll walk through a demo. So let's quickly introduce our demo app. So it's just a simple ASP.NET Core app. I just did .NET new MVC, I think. I did add Entity Framework Core, and to make things simple, I just grabbed the EF Core sample data model. If you go search Microsoft's documentation for getting started with Entity Framework Core, this is the model that they show. It's meant to mimic kind of a blog sort of thing, where you have individual blogs and each one has one or more posts. I guess 0 or more posts. But super simple, 2 entities and one relationship between them, and that's it. So building on top of that, we'll use a simple controller. You can see I've actually collapsed all the boilerplate stuff that you get out of the box, and I added this results method. Super simple. It's not doing anything fancy. It's a little bit more than just pulling back everything in the post table, just so it's not super contrived. But all we're doing is expecting an int as input. We're calling it threshold, and we're basically returning as JSON all of the posts that have a post ID greater than that threshold. Not necessarily a meaningful sort of API endpoint, but it'll do the trick for this discussion. One thing to notice is that I'm intentionally not using dependency injection for the blogging context, for the DB context. If you're familiar with ASP.NET MVC, especially .NET Core, you'll know that it really likes dependency injection, and actually I do too. But I'm not using it here completely intentionally because I want to show the progression from here to there. One of the reasons is that lots of monoliths either started their life before dependency injection really became popular, or for one reason or another, they were designed without taking dependency injection into account. Either it was determined to not really suit the goals, the architectural goals at that point in time, or maybe there was some other reason. But it's not uncommon to encounter a piece of code that doesn't use dependency injection. So I wanted to show how we deal with that as we go through the examples. Of course, that's a very simple example. We all know that as you start out, you might build just enough features to get going, just enough features to accomplish the goal that you're trying to accomplish, solve the problem that you want to solve for the world. But then you need to add features. You've got new features. You might want to enhance old features. Then you have deadlines. You might cut corners just in order to get something out the door. You might have demos. You might build a piece of functionality that's just good enough to demo to a prospective customer, but then it never really gets a full life of its own and is kind of languishing in that partially done state. Basically, you end up with technical debt, right? All software typically is designed well for the first set of requirements. Definition of well can vary depending on what your requirements are. But unless the architecture is constantly evolving as the requirements change, it quickly overstays its welcome and becomes more and more expensive to fix, right? The longer you have technical debt laying around, the harder and harder it is to fix, and the more expensive it's going to be to fix, the more bugs it's going to be causing, and that sort of thing. So what does that look like? So in this case, we still have our results method. It takes in a threshold, but we added pagination, right? The ability to skip forward a certain number of records and then take a certain number of records. Named skip and take because that's what the .NET link framework likes to use. And basically here we have our, on line 25, we have our original query, but then we're adding a skip if that's relevant, and a take if that's relevant. And then we're still returning JSON, but we have some additional logic in here. And then, of course, you get to a certain scale, and then you start asking the question, can we improve things? And these things might be a variety of different things. Performance is usually a big one. Security is another one. Maintainability, other sorts of things. Basically, you want to measure certain aspects of the code. So let's talk about that a little bit. Typically, you start out just by adding features, but then you want to start measuring things, and maybe you even go straight to the question of can we make them faster? Hopefully, you stop at how long are things taking before you go straight to can we make them faster, because can we make them faster is difficult to quantify if you don't have those measurements up front. But depending on your organization, you may have gone straight to the can we make things faster without stopping at measurement first. Either way, you end up with something like this. Of course, my tooltip is covering up this stopwatch. But stopwatch is something that's built into the .NET framework. Basically, I'm starting the stopwatch before running all the logic that was in the previous method, and then regardless of whether we succeed or fail, we stop the stopwatch, figure out how long it took, and then log that information. Right? So we've got a lot of stuff going on here. We have the original query, we have the features that were added to it, and now we have some performance benchmarking. And this actually doubles the length of the method compared to the previous example, which itself tripled or quadrupled the length of the method compared to the original implementation. So we're talking, what, 8 times the amount of code in this method compared to the code that satisfied the original requirement. So we've got some problems there. And if you end up doing this in or something similar in a lot of different places, you end up with duplicated code. It's really easy to end up with duplicated code when you're doing something just as simple as this. So let's start on our journey toward making it better, and ideally going toward a microservices architecture. The first step is dependency injection. DI is pretty much expected these days. It's kind of assumed that you're going to be using dependency injection. Many web frameworks especially kind of default to providing some way of using dependency injection. You kind of get a DI container kind of out of the box, or at least an IOC container, inversion of control. It might not be dependency injection, it might be more along the lines of the service locator pattern. That's still better than not having either of them, but we really want to get to dependency injection. If you're not using DI in an area of your code, you can pretty much guarantee that it's going to be tightly coupled, it's probably untestable, and its maintainability is definitely called into question. It's a lot easier to test, a lot easier to maintain code that is built with dependency injection in mind, not necessarily because of dependency injection directly, but because code built on top of dependency injection also lends itself toward better readability and that sort of thing. Now, if you can't use DI directly, and there are definitely some good reasons not to, you can use something like service locator, or at least runtime activation of an object that itself leverages DI. So basically, instead of calling new, or new your type, and then passing in a bunch of dependencies, you use the runtime's support for activating those objects, and it fills in all the dependencies, rather than you having to pass them directly to a constructor. The goal here is that rarely, if ever, do you use the new keyword or whatever your programming language's functionality for calling a constructor is. So with that in mind, we do need to change the DB context a little bit to support dependency injection a little bit better. There's some functionality built into the entity framework core infrastructure that uses this particular constructor on line 9. So the constructor is blogging context. It takes a DB context options of blogging context and just passes it to the base constructor. That's all that we need in order for the dependency injection built into EF core to work its magic. The other upside here is that we don't have that hard-coded path to, in the previous examples, it was a SQLite file. And in this example, it is too, but we're not hard-coding that into the constructor of the DB context. So this changes our, so another thing we can do is we can extract the timing and benchmarking code into its own class so that we don't have that duplicated code all over the place. And we can register this as a service that we can inject at runtime using dependency injection. So in this case, we basically create an iLogging stopwatch. It just has a single method called run. And really all it does is it runs a given action with a specified return type of type T. This is line 9 I'm looking at. And then in the implementation, line 21 basically through to the bottom, you can see it invokes the action in this particular implementation, but it starts the stopwatch, it stops the stopwatch regardless of success or failure, and then logs that. So it's basically all of the code we added in between the last example and the example before it, except we're doing it in a class that's specifically responsible for that functionality. So in order to make this all work together, we do need to make a couple changes to the place in code where we register all of our DI services. In ASP.NET Core, this is in startup.cs. So you can see line 29, services.addDB context. So here's where I'm registering the blocking context. And you'll notice that I did end up hard coding the SQLite database here, but at least it's not in the object creation, it's in service registration. So for this example, that's fine. Obviously, for production, we would want to pull that information from environment variables, a secure configuration vault or something like that. But this is one place where we can register that as a dependency that we can inject into other objects. And then on line 31, we add the logging stopwatch as the implementation of iLogging stopwatch, so that other classes can depend on iLogging stopwatch, and when they get created, they will receive an instance of logging stopwatch because it satisfies that dependency. All right, so now what does our controller look like? You can see we've shrunk the method. It's about half the size from the previous example, back to the size that it was in the example before that. And we do this by declaring the DB context and the logging stopwatch on line 18 as dependencies to be fulfilled at runtime. And then on line 27, we use the stopwatch. And then line 29, we use the database context as opposed to creating a new one inside this method. This makes the method significantly shorter, as I mentioned already. It makes it much more testable. You can mock out context, you can mock out stopwatch. For testing, you can even make stopwatch a no-op if you don't really care how long the method took, if you're just focused on the functionality. Just so that you don't have that other stuff going on. You don't have extra logging that you need to look through if there's an issue, that sort of thing. There can be many different reasons why you might want to swap that out for something else. Or you could create a new implementation that, say, exposes the timings for some other observability throughout the testing. Just exposes those timings as a property or something like that. But the method's still long. It doesn't have a great separation of responsibilities. And in particular, it makes some assumptions about the structure of the data store. So in this case, we expect a blocking context, which that should be a red flag because that's a concrete type. And it expects a property called posts, which we can assume is an IEnumerable of post or something like that. But there are some kind of assumptions that are being made about the structure. Not necessarily to the extent that it assumes there's a table called posts, but not far removed from that. This does make it a little bit challenging to mock, but this can make it challenging to mock, but we'll see how we can resolve that in the next step. All right, the next step is what I'm calling service injection. So it's a kind of a step beyond dependency injection, where we think more strategically about how each dependency will be used and how it makes sense for them to be kind of brought together into discrete reusable components. Specifically, we're going for separation of responsibilities and single responsibility where possible. So what we're going to strive to achieve here is that we really want the controller action to look something like this. We still have stopwatch.run, but we have a post service that we're depending on in line 18, and we're just asking for a list of posts that correspond to a certain threshold with a skip and a take. Right? That basically means the single responsibility for this method is not getting posts. the single responsibility for this method is receiving a request, fulfilling it, and then returning the response as JSON. It's as simple as that. Actually getting the post and actually filtering for the post will be the responsibility of the post service rather. And then of course we already have the stopwatch whose responsibility it is to handle that timing. So what should post service look like? Probably something like this. So obviously we're calling a list method and we're passing 3 parameters to it. Those 3 parameters mean threshold, skip, and take in order. And then one possible implementation of iPost service is this DB post service, which obviously it depends on the database. So it will register a dependency on line 16 on the blogging context. And then we have the implementation of running a query against the posts table and taking into account a skip and a take. And yes, if we were doing this a lot more, we could probably abstract the skip and the take out into something like a query pager so that we could reuse it for a post service and a blog service. And if we had any other tables, we could use the same, exactly the same logic, just template it out for different types and have it just implemented in one spot. In order to use that, obviously we need to add the implementation to our DI container. So line 32 will register iPost service and its dependency or its implementation of DB post service. And with that, we've really achieved the point of the talk. From here, the jump to microservices, if you wanted to go there, is actually pretty trivial. You just wrap the functionality of DB post service in a web API or something like that, and replace this registration on line 32 with an implementation that calls the post microservice instead of the DB post service. And then you can scale it out however you need to. You could separate those out into separate processes, install them in different Docker containers, install them on different VMs, and you could scale out the post service across multiple machines, horizontally scale, whatever you need it to do. But at this point, you have to change very little code throughout the rest of the application. Everything just uses the services. So what does that actually look like? Since this talk is titled From Monolith to Microservices, we might as well just go all the way through to microservices and show what that looks like. So let's add a new implementation of post service. We'll call it Web API post service. And all we're doing here is creating an HTTP client. And when we call list, we call off to a URL, which is obviously garbage here, but obviously you'd replace this with the actual implementation, the actual location on the web of the post service, and maybe add some authentication and that sort of thing. And then, deserialize the result, maybe do some error handling. That would probably be a good thing to do as well. This is just kind of a simple implementation. And then you return that, obviously as an iList of post or an IEnumerable of post or something like that. And because of all the work we've already done, that implementation is fairly trivial to do. Then on line 32 in startup.cs, we replace the registration of iPost service is implemented by DB post service. We replace that with iPost service is implemented by Web API post service, and boom, now we have a dependency on the Web API version and not directly on the database. Now, if you wanted to, you could make the choice of whether it was using the Web API post service or the DB post service based on some configuration. And this place right here is actually a fantastic place to do that. As the app starts up, it looks at your configuration and determines whether it should look at a local database or over at a Web API for that post information. And from that point on, all the rest of the code is exactly identical. because you're talking to an interface and an interface on top of a service, as opposed to a direct implementation to a database or a web API or something like that. And then in your controller action, you do exactly nothing, absolutely nothing. Everything stays exactly the same here. Because we structured our code this way, the only changes we have to make to use the microservice are in the dependencies, not in the code that uses those dependencies. All of our tests for this code are still valid, and we can still be just as confident that our code will run flawlessly, assuming it did before as well. Now, of course, this all has to do with web APIs, and the examples that I've used have been purely in, well, mostly in controllers. I was going to say MVC, but we didn't really see much of models. Most models are basically record objects, just storing data, not much functionality. So those don't really play into this discussion. But what about the UI? What about the V in MVC? And in fact, maybe we should actually not talk about the view so much. We talk about model and controller and not so much about view. So far, we've basically ignored the UI. And the reason for that is that there's very little consistency in the UI realm. So it's a little difficult to give an example that will apply to everyone. Some monoliths mix the UI code with the top-level business logic. This is common in something that maybe started in PHP, for instance. Others split it out into its own set of files. This might be the case with, well, maybe even .NET MVC, or maybe you have React or Vue or Angular as your front end, and you have a web API on the back end. Just because you have that separation doesn't mean you're not dealing with a monolith, because the back end might still be a monolith. You might have good separation on the front end, but where you need to focus most of your attention might be more on the back end. Some monoliths also implement the UI in the same language as the backend code. .NET MVC is actually a pretty good example of that. The views are Razor, which is basically C#, and if you're using Node.js, you've got JavaScript on both the front end and the back end, whereas others might use different languages. You might have HTML, CSS, and JavaScript for your front end, and then your back end is Python, C#, Node, whatever. But the guidance is still the same. Treat the UI as its own service. Actually, it's kind of the service that starts it all, which depends on other microservices behind the scenes. But let's use an example. Let's use a diagram to talk about this. So what we've talked about up until this point has been mostly the bottom half. And I've added some bits and pieces in to kind of be the glue between some of the pieces I'm adding. So we talked about that straight line at the bottom, REST API to post service to database. Maybe you have other services, and it probably makes sense to tie them together with some sort of API gateway, either your own built from Nginx or something like that, or maybe you're using AWS or Azure and using their functionality for API gateway. So we're going to kind of ignore that bottom half pretty much for the rest of the talk, because we've already talked about that in the first part of the talk. The left side is kind of the glue that holds it all together. We've got the internet, and we've got a CDN, and that's more implementation details. That's kind of one way. I would say the best way, it's my favorite way. This is how I do it, to kind of distribute traffic from the stuff that's API oriented to UI and static assets. So this is assuming that you, starting with a single monolith, everything's running at the same domain name, myapp.mydomain.com. If you have a bunch of traffic all going to that same domain, but everything under /API needs to go one way, and everything under /UI needs to go a different way. A CDN can do that for you, and an API gateway can actually do that for you. But if you're moving things to static files, JavaScript, HTML, CSS, an API gateway is kind of overkill. A CDN is probably the better way to go. You might already have static assets, and that's an obvious way to get some traffic off of the dynamic backend with a CDN. It's really easy to configure the CDN to pull things from, say, your images and styles and JS directories, whatever you call them. Pull those from like an S3 or just a static file share somewhere. But the goal really is that UI box in the middle. And this is where I would start putting all the UI layer. So start building a segmentation between the backend functionality, even if it's in MVC controllers. Start moving the things that are in. We'll continue using the C# example. Start moving the things that are in the your .cshtml files into just HTML files that pull from an API. So you still have the controllers, but rather than returning a view, have them return JSON of the model, and then kind of separate them out that way. So what works well for this sort of scenario? JavaScript works really well. If you're already using React, Vue, Angular, or I recommend moving to one of those things. You could also do HTML with just regular Ajax. There's nothing wrong with that. You can also do client-side Blazor, or Blazor with WebAssembly. So if you're not familiar with Blazor, Blazor is Microsoft's relatively new implementation of a .NET runtime in the browser. So you can actually write your UI in C# as .NET assemblies. They get downloaded to the browser and run in the browser as WebAssembly assemblies. So what doesn't work as well? ASP.NET Web Forms doesn't work so well. Razor Pages also don't work so well. And then server-side Blazor. And the reason those three things don't work so well, and again, we're talking C# here. There are other examples in not C# land. But these implementation technologies don't work so well because the UI-related business logic and the UI code itself is very tightly coupled. So you get logic code, C#, or ASP.NET Web Forms, you might still be using VB. You have that interspersed with your HTML, and that becomes very difficult to untangle. You end up probably just having to rewrite that entire layer. So you take let's say an ASP.NET Web Forms page, and you would turn that into an MVC controller with at least one method, and you would also write a brand new HTML page or React or Vue component so that you can separate those out. But you would probably have to basically rewrite them from the ground up. And basically what you're going for here is probably some sort of model view model, MVVM on the client side. That's typically how React, Vue, and Angular are described, though they definitely add some additional functionality on top. And then with MVC, again with the V in parentheses, so mostly model and controller on the back end, a web API sort of thing. The other big question is, when should you go between these stages? It's definitely never too late to add in dependency injection. I definitely recommend you doing it as soon as you can, even if you think this code has been around for so long, there's no point in adding dependency injection. There's always a point in adding dependency injection. It's also never too early. Even if you're just starting out writing a monolith, you might as well start off on the right foot and start introducing dependency injection, because it's a lot easier to do everything else if you've started there. There can very easily become situations where you if you don't use dependency injection, you end up with lots of cycles of creating new objects, and then those can be very difficult to detangle later on. The sooner you detangle them, the happier everyone will be, and the easier it'll be to get to a scalable architecture like this. Similarly, single responsibility is something you can always be pursuing, even after you move to microservices. So just because you've moved to microservices doesn't mean you're done refactoring. You can always be refactoring to make your code better, and single responsibility is one of those things that you should always be looking and always be evaluating. Is this function, is this method, is this class really only doing the one thing that it is supposed to be responsible for doing? As for moving to microservices, I think that there definitely is a right time and therefore also a wrong time. I think if you move too early, you end up with administrative headache, you end up with context switching all over the place. I found that out personally. I've started building my own projects into microservices architectures probably prematurely. And I end up in this situation where I have to write code in one place and hope it works, and then move over to another place and use it and find out that it didn't work, and then go back to the first place and just go back and forth. And yes, unit tests and integration tests can help with that, but there will always be a disconnect between the requirements that you're using to build your microservice and the requirements that you're that actually come to be when you're consuming the microservice. And the smaller you can make that gap, the easier you'll be, especially if you have a limited team. So if you're just a single developer, unless you're trying to distribute one portion of your application and not another portion of your application, there are some pretty contrived examples there. But if you're just a single developer, build a monolith. There's nothing wrong with building a monolith. You can build a scalable monolith. If you have a limited team, you can also run into those same sort of pitfalls. So if you don't have enough people to work on all the individual microservices continuously, or as they need to be worked on, just build a monolith. The only exception to that is that if they're isolated and independent enough to clearly and verifiably satisfy requirements continuously, then you can separate them out into a microservice, even if you're just one developer. Examples of that are things like authentication. So you could build like an authentication service that everything uses, and that you can pretty clearly test. There's pretty clear-cut requirements, and you can be continuously testing that. Logging is another thing, and that's absolutely isolated and independent, right? Or things that are already their own service. If you already have something that was built as a microservice, don't build it into something else and bring it into the fold just to make a monolith. If something's already a microservice, leave it as a microservice and continue to test it as its own microservice. But make sure that you have clear requirements, clear verification criteria, so that it doesn't suffer from being a microservice that you don't have enough time or the attention span to deal with on a regular basis, and then it languishes and the overall quality of the would-be monolith suffers. So with that, I'll conclude this video. I hope you liked it. I tried to build something that I thought would be appropriate and interesting to a wide audience, both beginners and people who have been doing this a long time. This is something that I've come across again and again at pretty much everywhere I've worked. Everyone has something that's a legacy piece of software. Everyone wants it to be better, nicer, shinier. And this is something that I've done for a lot of different apps, both my own and at startups and at some other larger companies. Sometimes this is not necessarily 100% achievable. either because of political or technical issues, or maybe there's something else going on. If you have questions about that, definitely leave a comment below or shoot me an email. And please subscribe to the channel and like this video if you learned something or are considering applying anything you learned here to your own projects. If this is something your company is looking at doing, which hopefully you are if you're not already there, share it with your colleagues. Thanks for watching, and I wish you the best in transforming your own projects to services.